My name is Giovanni Castiglioni, and I will talk to you about self-supervised deep learning methods for brain MRI. Deep learning methods play a fundamental role in solving tasks like image classification. With these approaches, usually we take huge amounts of labeled data and we train neural networks by showing them images and revealing what kind of content they have. Then we show new images, and if the training process was correctly performed, the machines will show good performance when classifying them. However, when we enter the field of medical imaging, particularly magnetic resonance imaging, just like before, we have lots of data from a variety of sources. But when we try to apply deep learning to solve problems, like to check if an organ has a tumor, we face several challenges that arise from the nature of medical imaging. Scenarios to deal with, such as multi-sequentiality, where different types of MRI sequences provide different information to radiologists, scarcity of labeled data, and the need for interpretability in machine decision-making processes complicate the application of deep learning in medicine. To overcome these challenges, we are developing innovative deep learning models using other approaches during the training stage of these networks. These approaches correspond to the field of contrastive self-supervised learning. With this approach, labels are not needed for training neural networks. Instead, two views are generated for each image in our dataset using data augmentation transforms. We then build an encoder model to extract features that represent these views. The resulting representations are projected to a lower dimensional space where all the feature vectors are compared, and as natural as it seems, we adjust the parameters of our model to get the two views that come from the same image to be close between them and far from other vectors. This results in encoders capable of extracting features from medical images, enabling us to train smaller classifiers with less labeled samples to fulfill their tasks, using the encoder's model's features. Once this process has finished, we use explainable AI methods to validate the obtained results and better understand the decision-making process of the AI models. The outcome is a model capable of solving its task given a few samples of labeled data, while also dealing with the black box behavior deep learning is usually associated with. In this example, you can see the results of distinguishing craniopharyngiomas among other types of tumors of the cellular region of the brain. I hope I was able to show you the great potential of self-supervised deep learning methods for brain MRI, especially for diagnosing craniopharyngiomas. Thanks for listening.